Hello, hello. Are we live? I might have a longer stream delay than usual. Not sure if I'm live yet. Looks like it. Alright. Everything seems okay. Let me make sure my chat is working. Okay, yeah. Took a second, but audio and chat and everything seems to be working. So, this is Advent of Code 2024, day 5. Let me run my auto downloader. I should have input. Something happens halfway through. More than halfway through. We've got two numbers with a pipe in between them for most of the file, and then we have a blank line, and then we suddenly have something else. Comma delimited longer lists of numbers, many more than two, maybe about 20 numbers or so to a line. What is this? That's like 23 numbers in a line, roughly. At most, frequently less than that. I will need test input too. And it's time to look at the puzzle, which I haven't seen yet. So we have multiple sections. And what is up with my copying and pasting? I think that should fix it. Okay. Yeah, really, what is going on there? Copy, paste, inserts, extra new lines. I'm using NeoVim in Tmux through WSL. I'm guessing at least one of those things is relevant. It's not consistent though, like, it's only like maybe every 10% of lines has an extra new line. It's nothing like that. It's probably gonna... Callie, you can't be up here, come on. You stepped on my keyboard yesterday. You're not allowed to do that. Not allowed to do that, okay? Yeah, so I'm gonna look into that later. I don't know what's up with the extra new lines. Sleigh launch safety manual. X and Y. What? Page numbers. X and Y. Not locations. Okay, so these are ordering rules. I don't know. What is a full stack overflow dev? Okay, so these are the ordering rules, and then I guess we have to figure out whether each line is in order or not. Is that a setup to a joke? I'm waiting for the punchline. If so, or is it just a regular question? Which updates are already printed in the right order? Callie, come on. You can't do this. No jumping, okay? It's not allowed. Saw it in a meme. Full stack overflow dev. Well, it's so full stack. A full stack developer is somebody who knows front end and back end. But then Stack Overflow is something else. So this is like one of those Jeopardy before and after categories where the word stack can be part of a phrase of the two words before it, and stack can be part of the phrase of the words after it. So it's some kind of play on words, I guess. But I don't know if I get the context. It's hard to tell whether it's referring to Stack Overflow as in an error or Stack Overflow the website. I mean, the website is named after the Stack Overflow error. Hey, Vision for All, welcome back to the stream. I am working on Advent of Code. So if you haven't heard of Advent of Code, they're a series of leet code style puzzles, and in the month of December they come out once per day. So I've been doing these all week, and they're Christmas themed. So there's a story here, but I actually skip the story. I just get straight to the puzzle. Because the first, oh, so it's not every page. It's just a subset of pages. Yeah, this is a software development stream. Okay, so we're looking for the rule breakers. Violates the rule 9775. That one's trivial because they give you this rule, apparently. 9775. That's right here. And then in this list, they show you those two numbers right next to each other. So that's not so difficult to see. Same here. The rule breakers are right next to each other. This one is breaking several rules. So I'm concerned that, like, what if you have 1329, but you have another number in the middle? That would be more difficult to find. Correctly ordered updates. So it's just the first three, right? Callie, come on. Not allowed to do that. Okay, finding the middle page does not sound difficult. Yeah, she likes to jump on my desk to get attention. It's pretty effective. Well, it actually just kind of makes me mad at her. So I don't know if that's the kind of attention she's looking for. I think she wants food. Hey, Frog the Catman and Geosman, welcome to the stream. I have a wheelie chair, and I'm really trying to not run her over with the wheels. It's hard because she's right next to the wheels. That's dangerous, Callie. Okay, so today seems a little more difficult. They added elves to the computers. Yeah, they're like machine elves or something. So we could kind of brute force this. This is... I mean, can I brute force this? How big is the input? It's... You have more than 1,000 rules. And then each one of these has about 30 numbers. Whoa. Couldn't brute force it for part 2. Yeah. I don't know. It's coming in part 2. This might be one of those days where I can only get part 1, and that's okay. That's what happened last year. Day 5 was the day where suddenly it was more difficult and I could only get part 1. So you could check every pair of numbers in this list. You can compare 1846 and see if that's a rule and if they're in the right order. Then you could compare 18 with 96 and see if those are in the right order. Then 18 and 13, 18 and 27, 18 and 49, all the way up until you do 18 and 67. Then... The ordering should be transitive. Power ramps after 5 like crazy. So then I think you also need to check 46 and 96, then 46 and 13, 46 and 27. So you have to compare each number in the list to every number after it. And there's a chance that some of these won't have an explicit rule. Do we have any 99s? What's like the biggest number that I have here? We have up to 98. Do I have 1 by itself? So we don't have every number. Do we have 9 by itself? Maybe it's just 2-digit numbers. There's not even a 10. We have an 11 and a 12. And there are some gaps, apparently, like there's no 14. For my inputs, at least. Everybody's input is different. So we have some subset of numbers between 11 and 98. I could kick her out of my office and then close the door, but the problem with that is it's going to get pretty hot in this room. Callie, come on. Hoping that she'll just stop interrupting at some point. That's what she did yesterday. She jumped up on my desk like 2 or 3 times, and then she just stopped and left me alone for the rest of the night. She just bit me. Oh, I probably shouldn't look at this. I should probably look at the test input because this is a little bit easier to deal with. So I'm looking through this list and just comparing pairs of adjacent numbers. 61, 53, 53, 29. So that's fairly straightforward. Every pair of adjacent numbers is an explicit rule. What about the second list? 97, 61, that's there. 61, 53, 53, 29, and then 29, 13. I'm guessing it's not always that easy. 75, 29, let's look at the third list, and then 29, 13. So I feel like these are not great examples because they don't really show every way that these numbers could be arranged. So I have no choice but to look at the real input. Yeah, well, maybe this list just isn't in order. 46, 18. Okay. So like we have maybe up to 90 numbers here. Psi, it's 90 squared, 8,000. I don't know how many numbers I have. I have numbers between 11 and 98, but there are gaps in the middle, and I don't know how many gaps there are. So if I had all 90 numbers and there was a rule for every pair of numbers, then I would have 8,000, roughly 8,000 rules. Hey, bald bearded builder, thanks for the raid. I really appreciate it. What were you doing? Were you working on Advent of Code? So I should at least be able to read my input. Okay, there's the test input. Now what the hell do I do with this? Working on some YouTube videos and a cheeseburger. Oh, just a literal cheeseburger? That's cool. The cheeseburger being the most important part. Literally the best cheeseburger ever. I do cook, but I almost never make burgers. I feel like when I have a burger, I want to have like a bunch of fresh vegetables like onions and tomatoes and lettuce, and I have a hard time keeping all of those fresh on hand. Like you slice into a tomato and then it just doesn't stay fresh that long. So I either have like one burger and I end up wasting the rest of the tomato, or yeah, I don't know what to do. Oh, you didn't make it? That's the way to do it. So I could just parse the input, but after parsing, I don't even have a strategy for how to check all of these. Let's look at the rest of the test input. Let's look at the ones that aren't in order. So I guess the last three are not in order. 75, 97. Is it in the other order? AOC kicks my butt every year. I haven't even attempted it this year. I was okay with the first 4 days, but today it's like it's suddenly difficult. So yeah, that one breaks one of the rules explicitly at the very first pair of numbers. Fourth update. Yeah, it's the first two. Fifth update. But what about the rest of the ones in the fourth update? So that's this one. What about 9747? That one is valid. 47, 61, 61, 53. Okay. Then 61, 13, 13, 29. But it breaks the rule, so it has this, but in the other order. Okay, and they said the last one breaks several rules. The first two numbers are okay. And then 1375, 7513, 7529, 2947. Maybe it's in the other order, 4729. Okay, so maybe I'm overthinking it. I'm trying to think of the general case where like maybe you have to compare these two numbers and they're not next to each other, or maybe you're looking at these two numbers and they don't have these two numbers in a rule. Like you have to figure out their order relative to some other mutual number and then use a set of three numbers to figure out if these two are in order or not. But from the test input, that never happens. Every pair of numbers that are adjacent in one of the updates, they explicitly have a rule. They're either in the right order or they're flipped, and there's an explicit rule against them. So I might be overthinking this. I mean, it's still kind of hard. It's still kind of hard to do this without brute force, because when you're looking at two numbers, do you iterate over this entire list or do you do something more intelligent? Maybe I can brute force part one. One of the commenters said I probably won't be able to brute force part two. So I don't know. You don't want to prematurely optimize part one, because then part two might be totally different, where your optimization from part one isn't even going to help you with part two. So I'd rather not overthink this. But I'm also thinking maybe I could do a couple things. I could find the unique set of numbers. So I could put all these numbers into a list, and you're going to have some duplicates, like 29 appears in here a bunch of times. And then you could sort the list not based on the actual numeric order, but sorted based on the ordering rules that they give you here. And as long as they give you a rule for every possible pair of numbers, which maybe they're doing, I think the first thing to do is find out what's the unique set of numbers. Like, how many numbers am I looking at here? And then did they give me every possible pair? Like, this is 21. 21 doesn't seem right. It's 21 and not 20. 20 would make sense because 20 is a factorial. But what would this be? If they give you every possible pair, I think it would have to be like n times n minus 1. And I don't think 21 matches that for anything, right? It's 7 times 3, but it's not any other product. There's no other factorization of 21. So I think they're not giving us every possible set of numbers. Anyway, let's parse the input, sort it, and then figure out what we're dealing with. So let me edit today. It's going to be day 5. This is just a template that I copied. I think I have to make a couple passes on the file. I'm going to read it once and count. Come on. Okay. That's what I wanted to do. I'm going to read it once and count how many lines are here before I get to a new line. And then eventually I might need to count this number of lists too. Or I think I could just process these on the fly. I don't really have to save all of them simultaneously. But I think I do want to save all of this. So on the first pass, we're going to count the number of rules. Are these called rules? Or order? Yeah, rules. Goal is to get at least 40 stars. I think that's a good goal. I usually get around 40 stars or a little bit more. And like it's not always great for my mental health. I think it gets pretty frustrating on some days. So who knows? Might not get that this year. 40 stars is a good goal there. Those last couple are rough. This might be off by one. Let's just test it and see if it's right. Okay, 21. That's what I was expecting. And then, especially when you feel like you're really close, oh yeah, it can be addictive. You're like, I almost have it figured out. I just need to fix one more bug. And then you fix that, and then you figure out that you have something else wrong. And before you know it, you've spent like 3 hours nonstop just on part one. Hoping this is not going to be one of those nights. Who knows? Okay, so now I can allocate an array for all of the rules. It's going to be 2 by something, so 2 by n rules, which we just counted in this first loop. And then, yeah, we have to close the file. Well, I already closed the file, and then we're going to reopen the file to basically rewind back to the beginning. And then save the rules on this second pass. So we read a string, and then I'm going to want to parse integers from that string. Can I just do it like this? Can I use a slice? I don't think I had this feature last year, so I'm not sure if I ever tried it. Rules, both of them for I equals parse I32 delim. We're parsing from the string, and then the delimiters are commas and maybe spaces. Or no, it's actually just a pipe. So for this part, the pipe is the delimiter, and then later on we might have commas as delimiters, but for this part it's a pipe. So does that even work? I'm not sure. I think it worked. 47 and 53, 47 and 53. And then the last two are 53 and 13. All right. Yeah, I was thinking I might have to parse this into a temporary variable and then assign this to that temporary variable, but I can just do it in one line. So those are the rules, and you don't know, like if I look at 29, for example, it only appears on the left once. So it's possible that there could be some numbers in these rules that only appear on the right side, or other numbers that only appear on the left side, even though they appear multiple times. So I think I want to combine these into one array that's like the same size, basically, but instead of 2 by n, it's going to be 2 times n, but it's going to be a rank 1 array. So we allocate it like that. And then I'm going to take like the first column of the rules and put that in the beginning section of numbers. And then I'll take the second column and put it in the second half of nums. So 0 through n rules, that's going to be the first column, or column 0. And then this is going to be the next column. So let me make sure I did that right. Okay. Looks correct. 13, 13. So you have 13 and then 13. That's like the last two numbers from the second column. And then there's a 29. That makes sense. 47, 75, 53. Not that. Looks like that's the end of the first column. And then going back, we have 75, 47, 97. Yeah, that all looks correct. So now I can sort this, and then I can sort it by any ordering. If I only need to find the unique numbers in here, I could just sort it by the usual less than ordering. I don't need to apply these special rules just yet. So maybe I'll just do that to simplify my life. You could like implement a bubble sort. Well, again, like I still don't know if they give you every possible rule explicitly, or if you have to like just figure it out based on a mutual common number in some cases. So we're gonna have sorted just be sort in place nums. And then this is still not unique, but now that we have a sorted list, it's easier to filter out the non-unique ones because they all appear right next to each other. So that seems to be sorted. Do I have... I don't have a unique helper function. I feel like I've probably done this at some point. Excuse me. Yeah, I've done this before. It's just not in my little library that I'm making. Does this language have a set data structure? No, it doesn't. Unfortunately. Yes, a set would be the way to do this. The way to do this. So it looks like I only had to do it once. 2023. And I did this last year. Unique. It's a vector. And then this automatically sorts, so I'm not gonna have to call sort myself before it. And then yeah, I think I want to pull this out into my utils. So this is 2023, day 21. Unique. Copy that. And then I actually don't have anything called sort in place. Or I don't have anything called qsort. Because this is using something called qsort that was also in day 21 from last year. But qsort is just sort in place. It's renamed here. So I don't really need to do that because it's going to do the sorting for me. Let's call it unums for unique numbers. I think I'm not great at picking variable names, so some of these are a little bit sloppy or lazy. But that's just my style. Yeah, I changed directories. Okay. Right, these are out of date. I should have copied this from somewhere else, but I think all I need to do is return UT. There we go. Okay, so this is the unique set of numbers. We have 1, 2, 3, 4, 5, 6, 7. You have 7 numbers. Seven. They do give you every rule. It's 7 times 6 divided by 2. And that's 21. Right? Because this list is 7 numbers long, and then 7 times 6 divided by 2, that's 21. Okay. So this might not be as hard as I was worried it would be. Because if you want to have every possible pair of these numbers, you have 7 possibilities for the first number. And then you have 6 possibilities for the other number, because you don't have a choice of all 7. You don't want to have the same number twice. So it's 7 times 1 less. That's 7 times 6. And then your pair could be in 2 possible orders, but the rule is that it's only going to show you one of those orders. So it divides by 2. That's why this number of pairs is 21. Okay, so we've parsed part of the input. And then what do I do next? First of all, I can clean up some of these buffers. I don't need day 3 or its input. Okay. So we've read this much, and then I think we have to skip the new line, and then we can read the rest. I don't know if I'll actually need these. It might help us with optimization later. So at this point, we can start reading until the end of the file. But I think I have to read one more line just to skip the new line. Or skip blank line. And then, while we're not at the end of the file, we're going to do that again and just see if I got all of them. I think I have to do this twice. And then we have one right before the loop, and then inside the loop, this is actually going to read past the end of the file. So on the last loop iteration, this is going to return an empty string. So that's why it's at the end of the loop. Then did I get all of them? 75. There are 6 of them. And yeah, there are 6 of them. So I think that's correct. All right, now we have to figure out if each one of these is in order. So I think this is called an update. I don't like the word update. It's confusing. I'm just going to call it V. It's a vector, and we're going to figure out if this vector is in order. So let V equals parse I32 delim again, and then we're parsing from the string, and this time the delimiters are commas. That seems correct. And it just figures out whatever size it needs to be. Sometimes we get 5 numbers, sometimes we get 3. And then we can figure out if they're in order. And do I want to do this a brute force way, or do I want to do something clever? I think we can do it brute force initially. That will at least work for the test input. And then we'll see how slow it is for the real input. And then if I can get a right answer that way, I can think about optimizing it and see how different part 2 is and think if that optimization is going to help me for part 2 or if I need to optimize something entirely different then. So we're going to check if each pair of adjacent numbers in, the puzzle calls it the update, so I'm going to put that in quotes. Vector v is in order, or in the correct order. I think if you say in order, that implies that it's in the correct order, but let's be explicit. So that's going to be a loop for I in 0. We're going to have the size of this vector. Size v0. So the loop is going to go up to nv minus 1 because you're checking 2 numbers at a time. So it's going to be the size of the vector minus 1. And then basically we're going to have vi and vi minus 1 and see if those are in the correct order. But we're not using the usual, maybe less than is more appropriate. We're not using the usual less than ordering. We're using the ordering according to these rules that we parsed earlier. And to figure out if they're in order, we're just going to iterate through the entire list of rules. This is going to be the brute force part. So this loop is okay. You're going to have to do this loop no matter what to check if things are in order. You're at least going to have to check pairs of adjacent numbers. Maybe for some more general case, which I don't think the puzzle covers this, you might have to check more than just pairs of adjacent numbers. You might have to check like the first number in the list and see what its order is compared to the last number in the list or some other number that it's not adjacent to. But hey, I'm hoping we don't have to do that. So this is the question that we want to answer. That's a question. So we're going to go through the rules, and I'm going to do it the brute force way, so it's just going to be a nested loop. If you wanted to optimize this, you could look up your number in the unique list of numbers and then have some other mapping that tells you what all locations does this number appear in the rules, and then just iterate over that subset of the rules rather than checking all of the rules for every pair of numbers. So we're going to do IR in 0 to n rules. We're actually going to compare to I plus 1 because of the way that I'm looping. If I looped from 1 to nv, then it could have been I and I minus 1. So either way would work. I think I want to pull out some local helper variables. So vi, we're going to call that va, and then vi plus 1. And then if all, you could do all or you could do and maybe it's going to be clearer if I do and, because we're only looking at two things. It's not a huge list that we're comparing. So if VA equals rules 0 IR and VB equals rules 1 IR, that's actually fine. That means this order is allowed. And if we find it, we can actually break out of this loop because we found the rule that tells us how to compare VA and VB. So we're going to be able to break out of this loop if that happens. Or the other case that concerns us is if they're in the opposite order. So we're going to swap VA and VB here. And we're going to have some kind of Boolean that says if they're in the right order or not. False. So this one is the correct order, and then this one is the wrong order, but in either case we can break out of this loop. And then if at this point we found two numbers that aren't ordered, then we can also break out of this loop now because we found two numbers that aren't in the right order. We don't have to check the rest of the list. It's already breaking the rules. So we can stop that loop at this point. But I'm going to need to know that, so I need to move this into another scope. Line 8. Sorry, I have relative line numbering on. I think you mean either this one or this one. Continue. I think it's not really going to save anything. Is it this line? Yeah, so if you continue here, you're not going to do anything. Actually, yeah. No, because if we've entered this if branch, then there's nothing else inside of this loop. So if we've entered this branch, we don't even have to check this condition. So that's going to get skipped no matter what, and then that means this whole branch is going to get skipped no matter what, and then we're already at the end of the loop. So logically it would be okay, but it's also not going to change anything. So I need to put this in a different scope. I need to declare it up here because then I'm going to want to remember if it's ordered at the end of the loop. But I do want to reset it to true. So I don't want to delete this line entirely. I just don't want to re-declare it with let. And then out here, if ordered, we're going to have to get the middle number and then add that to the sum to get the answer. So sum plus equals V, is it going to be NV divided by 2? Yeah, I think that should work, because then if you had three numbers, 3 divided by 2 with integer division would be 1, and with zero-based indexing, 1 is the middle number in a 3-number list. So it's just NV divided by 2. That might be it. I might have some logical problem in here. But let's find out. 143. I cannot remember at all what the expected answer is. It was so long ago that I read this. I've been streaming for 50 minutes already. 143? Okay, let's see how bad this brute force is. Let's see how slow this runs with the real input. It might take a minute. Not bad. Might not be right, but it ran quick enough, less than a second. 54:52. I'm surprised, honestly. Okay, let's see what part 2 is about. Okay, so now we have to sort. But with weird sorting rules. Okay. So, yeah, it's very closely related to part 1. So I think it might be worthwhile to optimize part 1 and then work on part 2. And before I start optimizing, I think I want to commit what I have so far, just in case I fuck something up, then I can just undo and go back to something that worked. I added a couple comments to day 4 and, well, added one comment and then deleted 2 things that were already commented out anyway. So that's why there's a diff. And then we just added this unique function to utils. It actually came from 2023, and then I just copied it into my utils library. This is just a little library of helper functions to do things like string processing and sorting and getting the unique elements in a vector. Day 5, part 1, brute force. So I might try to optimize this. I think I committed everything. Let me make sure I pushed. All right, that's the code that we just wrote. Do I need a bisection search now? Callie, come on. You can't be up here. This is my little stream interrupter. Come on, Callie. So the way that I did it here is I checked all the rules by brute force. So how could this be optimized? instead of iterating through every single rule and rules, what you could do is look up where does VA happen in my list of unique numbers. So we have a list of unique numbers unums, and to look that up, the optimal way to do it would be with a bisection search, and I think I need to implement that because I have sorting, but I actually don't have a bisection search anywhere. And then you can look it up in this list in order log n instead of order n. This is actually going to be a small number, so maybe I can like just brute force the search but optimize everything else. It's hard to tell if that would be more optimal or not. Come on, Kelly. And then after you look it up, I'm going to need, or before I look it up, before the loop even starts actually, I need to construct a list that says in which locations does each one of these numbers appear in the rules. So I think I need to construct that first. And then once you look it up, you only have to iterate over the subset of rules that this number appears in instead of all of the rules. And then if we have that, I think that's going to help us optimize part 2 as well. Is this even worth optimizing? I mean, the thing is, part 1 ran in less than a second. Hey, F. Hinkle, welcome to the stream. So it ran in less than a second and it logged a bunch of stuff too. So what if I just like turn off logging? Still pretty much the same amount of time. And we're doing some stuff that we're not currently using. Like we're calling unique, which does a sort. But I'm not using that yet. So it still takes like 0.6 seconds no matter what. I don't know, should I just try to brute force part 2? The other thing is, which sorting algorithm do you implement? If you implement bubble sort on top of a brute force, then that's going to be slow. But if you implement quick sort, which I have in my library, I'll have to copy and paste it because of this weird ordering rule. That's going to be faster to begin with, even if your ordering comparison is brute force. So if I do it like that, is it just going to be fast enough? I think maybe we should just find out. And I'm going to want to go back to the test input because it's smaller. Okay. Is this Fortran? This is actually syntran. This is my interpreted programming language, and it is implemented in Fortran. So the host language of this interpreter is Fortran. So at some level, you could argue that this is Fortran, but this looks nothing like Fortran. Most of the syntax is entirely different. Callie, come on. I think I should get some sort of like handicap bonus for the Advent of Code leaderboard because I keep getting distracted by my cat. They should just like cut my time by 50%. At least give me like a 10% bonus. I don't know what's fair. So I guess I'm going to just copy and paste part 1 and then get started on part 2 with some sort of brute force approach. See how bad it is. Cat is an unfair advantage. They should add to my time. I guess you have an argument there. She's not really very helpful with any programming advice, though. Hey, Callie, can you help me implement quicksort? Should I just use the middle number as a pivot, or should I take the median of 3 pivot? She doesn't even know what I'm talking about. Advent of cats. Hell yeah. Okay, so we have a part 2 here. And then it should say part 2 at the end. Okay. And I haven't changed anything, so it's just printing out the same answer as part 1. So now we're not going to do this. I think for part 2, they're asking us exclusively about the things that aren't ordered. So if not ordered, we're going to do something. Is that how this works? Just asking about the incorrectly ordered updates. Okay, so I think I need to move something else to another scope. No, I still have V. I thought V might be out of scope here, but it's still in scope. So let's just print those to see if we got the right 3 unordered lists, or updates as they call it. So 7597, that's this one, then 6113, and then 9713. Looks like we've identified the right 3. Now we have to do the hard part, which is sorting them. So I'm going to go into my utils and steal my sorting algorithm. So I have 2 versions of sort. I have sort index and then sort in place. Sort index doesn't really do anything with the input array, but it returns an index array, which tells you how to sort this. The other one is sort in place. It basically returns a modified version of your input vector v, where all of the elements are v in order. So for a lot of cases, this is more straightforward and more useful. But in some edge cases, you need to get an index array because you want to have the original array and the new one, and you just want to have an index array that tells you how to sort the array. Syntran? Were you here yesterday? Maybe I saw you in somebody else's stream. Yeah, syntran is my programming language, and yep, yeah, it's written in Fortran. So somebody else was just asking about this. Might as well show you that there's this website called Syntran Explorer. I'll drop this in the chat. You can play with this. You don't have to install anything locally, and then you can just run Syntran in your browser. So you can print a string, you can have a basic hello world example, and that'll show you your output when you run it. And then it has slightly more complex stuff here. Like this one's kind of cool. This is a Quine. It's a program that prints itself. So all of this text will be printed verbatim by the output of this program. And there it is. So some stuff to play with there if you're interested in Syntran as a language. All right, so we have to sort this thing, and I want to take sort in place. But I don't want to have the same name as something that I'm already including from that utils collection. So I want to rename this sort rule. So it's going to take a vector, and I think it needs to take the rules too. So I want to call this, I have to modify it to use the rules, but I just want to see what happens if I sort it. Wasn't able to do this one in place, and you ended up writing topo sort. I don't think I know what topo sort is. Some kind of sorting algorithm. Directed, oh. Oh, of a graph. Yeah, that's the trick. You have to think of this as a graph theory problem. Maybe I shouldn't look at that because it sounds like a bit of a spoiler. It's probably like the optimal way to do this. So what happens if I just sort this using the usual ordering? S is going to be the sorted version of V. Sort rule. Well, what it comes down to, I guess you just joined in the last minute, is how efficiently do you look up the ordering rules? And I'm going to see if I can just do that brute force. I don't know if it's going to be fast enough or not. And if I need to, I can try to start optimizing it. I have several ideas of how to do that by like building various lookup tables to look up where your number occurs in the ordering list instead of checking every single rule for every single number. She's knocking stuff off my desk. And she still hasn't told me if I should use a median of 3 pivot. Yeah, whatever I just said probably makes no sense. I sort of have to write the code, and then maybe you'll see, or maybe it'll make sense. So does that run at least? Tables. Okay, so this is sorted, but it's just sorted in numerical order, and that's not what they're asking for. They give us this weird made-up set of ordering rules, and I have to figure out how to apply that. Table-driven, yeah, they can be surprisingly fast. It depends how well you implement it. The topo sort thing that you showed is probably really the best way to do it. Why not start with brute force? Yeah, that's what I'm going to try. I'm going to try brute force and just see how bad it is. And if we need to optimize, then we can try that. So sort rule, and we need to give it the rules. Thought you were... I am doing quick sort. There are like different levels of brute force. So you can do brute force, but you can do quick sort, but you can still brute force look up the ordering rules. So I'm talking about like half. Yeah, I'm feeding the rules into quick sort. And actually quick sort is the only sorting algorithm that I have implemented here. So if I wanted to do bubble sort, I would just have to implement that from scratch rather than this, which I just copied and pasted. So it's easier for me to start with the better sorting algorithm. So we have rules, and rules is a rank 2 array. So it gets 2 colons there. Got some kind of spammer in the chat. It already got auto blocked by the auto mod. Topple sort. Yeah, I think Birdie was talking about topo sort. Maybe that's what it was. Oh, 2 out of order and then started over. Oh, that might be bubble sort. It sounds like bubble sort, and bubble sort is like order n squared, so it's not the best. Does this still run? Okay. So I have this declared correctly. And then I want to get the size of this array locally. Bastardized bubble sort. Okay, so how does this work? At some point, there are comparisons. So this is a median of 3 pivot. That's what I was joking about with my cat. That's That's a minor way that you can speed up quick sort. So it looks like I need less than, and I need less than or equals. If rules contain, yeah, I was really concerned about that, if they contain all the rules or if the sorting has to rely on transitivity. So what I did is I looked at, I don't have it printed out now, but I looked at this list and I sorted it and I found the unique numbers. So I figured out that there are 7 unique numbers in this list. And then they give you 21 rules, and that's every possible permutation. So I don't think you have to rely on transitivity. And whatever I did for part 1, it just kind of worked without me having to figure out any transitivity. So yeah, I was really worried about that. I was like, this might be really difficult if they don't give you every possible rule. Create a dict. The answer wouldn't be deterministic. I think they could leave out a few rules and you could deduce them from the given rules. Like, so what Finkel is saying by transitivity is, if they tell you A is less than B and they tell you B is less than C, then you can figure out that A is less than C, even if they don't explicitly tell you that A is less than C, because that's what the transitivity rule is. Yeah, I think Finkel just said the exact same thing. Now, there might be, if they didn't give you enough rules, you might never be able to figure this out. So, but there is a sweet spot where they could leave out one rule or a few rules and you could still deduce them. But that would make this really difficult. Callie, come on. Come on. Okay, I'm trying to figure out where all I have to implement comparison operations in here. And these are just comparing indexes. This one and this one. So I think I just have to do less than or equals here and less than in a few places. But if I skip the median of 3 pivot, then I don't really have to implement any of that stuff. Oh, you think both? Yeah. Yeah, if you make it into a graph, then you probably just take care of it automatically. H. I think I can just comment this out if I want to skip the median of 3 pivot. Is M used anywhere? Okay. So does that still sort with the natural ordering? I think that still worked. Okay. So if I comment out the median of 3 pivot rule, it might be a little bit slower, but then I save. I don't have to implement the less than comparison operation. I only have to implement less than or equals. So that simplifies things a little bit. And then this is just comparing an index to 0. So this can still use the natural ordering. This doesn't have to have any special ordering implementation. Same with this. So this is what I have to modify. So is less than or equal . Okay, so I have to implement this now. And we kind of did it in part 1 inlined. I'm just going to pull this out into a function. We're comparing A, which is an int, and B, which is an int. And then we're going to have the same rules as in the next function. And that's going to return a Boolean. That's not right. It's going to be size rules 1. So rules is 2 by the number of rules. So this is at index 1 of the size. And then this is basically going to be our function here. And this is the part that's going to be brute force, even though I'm using it within a somewhat optimized sorting function, which is quicksort, slightly better than bubble sort. Bubble sort is n squared, quicksort is n log n. So maybe I should just name these arguments VA and VB so that I don't have to rename them in here. And we're gonna let ordered be true, and then we just return ordered. Is that it? So that's some kind of funky ordering. 9775. Oh my god. 47, 61, 53. It's exactly like the check I did on my first solve. So this one seems correct. Let's check the other two. 61, 29, 13. 61, 29, 13. And then 97, 75. 47, 29. Huh. I think that worked. It's just the test input, so let's see how long it takes to run. I don't have an answer yet. I still have to sum up the middle number. Come on, Callie. Come on. I might be almost done here, and then I can feed you. You can get a little treat, and then you can have dinner soon. I wish I could, like, pivot a webcam and show you my cat, but she's going to stand where she stands, and I can't really get her on camera too easily. That was easy. I'm not really ready to declare that it's easy. I want to see. Maybe it's going to like take 24 hours to run on the full-sized input. So summing up the middle number is going to be pretty easy. It's moving pretty fast. Yeah, that's not bad. Okay, just have to sum up the middle number, and we already know how to do that. So copy that from part 1. And then instead of the middle number of V, it's going to be the middle number of S. That should tell us something. I want to check if, yeah, let's check if I can get the test input correct at least. Compare that to the sample answer. 123, pretty confident, yeah. All right, and then what did I get with the full-sized input? I have to run it. 4598. I've got a good feeling about this. All right, that was a day that looked challenging, and if they pulled that transitivity trick where they didn't give you all of the rules and you just kind of had to figure it out, that would have been way more difficult. So I'm glad they didn't. But then there's this topological sorting. I bet this would have just worked. No, well, no, I don't think it would. Because this relies on finding one of the rules. It will continue and it will just like return true by default. But if your rule doesn't happen to be in there and it never hits this, then it's like 50-50 as to whether it gives you the right answer or not. Check if it matches all the rules. Well, I'm only comparing. Yeah. I'm not sure. I guess that could depend on the sorting algorithm. So if you checked the list in a different way, you could still figure out if it's sorted or not. Yeah, I'm only doing one pass, at least for part one. For part one, I only did one pass, and I only compared pairs of adjacent numbers. If you checked every pair of numbers in the list, then it wouldn't matter. Yeah, and you wouldn't need to have all the rules explicitly. Come on, Callie. Come on. Okay, I think I have to give my cat a treat so she stops bothering me, and then I'll come back and commit, and we're gonna try to find somebody to raid. So give me like 1 minute. Okay. We'll see how long that keeps her off my back. It's just going to be a temporary solution. So I don't need to log all of this stuff. Let me clean that up. Okay, that should be cleaner. And it still runs in 2 seconds. Like, that's not bad. And are these the answers that I submitted? 5452. 5452 and 4598. Okay, that's still correct. And then there was really no point to doing part one as a separate commit because then I didn't really try anything risky. If you wait, 3 hours, Chancel? I don't think I know who Chancel is. I assume they're another AOC streamer. The main thing you've learned is just how fast Rust is. Yeah, well, Rust has fast runtimes. Is it faster than like C or C++? Oh, your channel. Oh, okay, yeah. I don't think I'm gonna wait. Actually, it's 4 hours. Yeah, sorry, I can't keep up. I can't keep talking for that long. I get tired after like 2 hours of streaming. The drawback of Rust is that it has slow compile times compared to C or C++. The borrow checking and stuff like that is a big overhead on compilation, but it doesn't affect the runtime. Like the runtime of Rust is still very good. Oh, you're gonna start early. Yeah, yeah. I'm kind of curious. Did you get part one and part two? Use JavaScript, no compile time, no type checking either. I think I want to put a comment in here. So we pulled something out into a function, but we never used it in part one. And there's something that I kind of skipped over in the comparison function. So what if they're equal? What if VA and VB are equal? I got lucky because this just returns true by default. But if this was is less than instead of is less than or equal, that would actually be incorrect, right? Yeah. Because if you compare a number to itself, it's not less than. It's less than or equal, but it's not less than. So then you would have to be very careful about returning true by default. Yours doesn't loop. It uses a better sort. It still has a lot of loops. Oh, your brute force solution. Yeah, I'll check that out in a second. So I just want to put a comment in here that is less than. If you had to implement less than, you would have to have a check if they're equal and then return early, and then you could actually skip the loop. But because this is less than or equal, it just happens to work. Did I look through the whole diff? And then I will look at the link that you posted. Whoa. And then I don't want to claim this 40 times faster benchmark because I don't know if it would be 40 times faster for today's problem. It might not be as much of an optimization. And this would need is less than to do this comparison. It really wouldn't be hard, but I'm lazy, so I'm not going to do it. Okay, and then I want to put my expected answer here. So those look like the same numbers. Plus 4598. Okay. With quicksort. I didn't have to do any optimization. I feel like I got lucky. Topo sort floored something inefficient, runs in, yeah, 3 milliseconds is very impressive. Like literally seconds. I took 2 seconds here. And syntran is slower than Python. So Python has a fairly advanced bytecode interpreter. I don't have that, so I'm even slower than Python. Like, what is this, 2 seconds? A little over 2 seconds. All right, let's see. Let's see Birdie's solution. What are you using time for? Is that just to profile yourself? Oh, yeah. I think so. Yeah. Okay, so you named it the same way that I did. Rules. Then you push that. Okay. Is this okay? This is just part 2 in one file. I tend to do part 1 and part 2 in the same file, but I know a lot of people do it this way too. So this would basically be your part 1, though. Oh, you have a better file. Oh, yeah. While not matches rules. I'm not really sure what this does, or it would take me a few minutes to read it. So is this like a bubble sort? I think you mentioned before that you tried something that was like a bubble sort. Gets the position of the val. Okay. And then you insert it somewhere where it's in the correct place. Final update. I think that's just a local variable in this function. Okay, cool. Want to see your better solution too. Topo sort update. So it has, oh yeah, hash map. Because I was thinking if I needed to update or if I needed to optimize my rules checking, instead of iterating through all the rules, I could have some sort of like faster lookup. Yeah, feel free to post your JavaScript. I'll check it out. I think a hash map is an even better way to look things up. I was going to do like a table lookup because I would need to make a hash function if I wanted a hash map. And we did that last year for Advent Code. There was one of the days where they made you implement a hash map according to some rules that they gave you. But for this, yeah, hash is a good way to look things up. Then you have a queue. Oh, this is topo sort. And then there's more than one post per pre. Yeah, your number can appear multiple times in the rules. we got Finkel's link too. I think I want to read more about topological sort later because I didn't know about this algorithm. All right, we'll check out Finkel's code. Is this part one or is it also part two? So this checks if it's... Oh, you overwrite. Oh, that's an interesting strategy. I guess there's always the commit history, so if you want to go back to part one, it's still there. Oh, and then, okay, yeah, there's the sorting for part two. I should have seen that in the list of functions. Hey, Dev Ninja, welcome to the stream. I finished day 5 here, finally. I don't remember how long it took me. I'll have to go back and rewatch. Yesterday, I finished in like an hour and 2 or 3 minutes. I guess today, yeah, it must have taken me longer, maybe an hour and a half or just under an hour and a half. So now I'm just looking at other people's code. Yeah, it gives you the functions on the right. This is a relatively new feature, and it doesn't support every language. Like, I wonder if I can go to like one of my Fortran repos. I can't remember if it supports Fortran or not. It does JavaScript. I know it. I saw it on Rust from Birdie's code. Yeah, I don't think we get any symbols for Fortran, so it doesn't support every language, but it's pretty cool for the languages that it does support. So this tab, nope, that's Rust. Yes, see, it has this too. All symbols, and then that's the list. You don't have that many functions, I guess. Is that correct? You never know. Like maybe GitHub has a bug and they just missed some functions. Cool. Yesterday was way easier than today. Yeah, yesterday wasn't too bad. Diagonals take a few seconds. Yeah, that was interesting yesterday. Most other Advent of code problems, they only have you check 4 directions. They have you go left, right, up, and down. And I don't think I've ever seen them make you check diagonals until yesterday. We finally got diagonals in Advent of code. Part 2 is easy for you. Some of my viewers had more clever approaches to part 2 than me. So everybody else seemed to look for the A in the middle of the X and then check the 4 corners. I didn't do that. I had like a 3x3 grid that I was sliding over the bigger grid and checking everything within that grid. So much copy and paste. I managed to do it without copy and paste. If you like encode your directions in a good way, then you shouldn't need to copy and paste too much. Oh yeah, some people disagree, saying day 5 is easier than day 4. For me, I think day 5 was harder. Honestly, I kind of just wasted a lot of time overthinking and being like, do I need to optimize this? Do I need to deduce transitivity rules? But in the end, it turned out no. I could just brute force everything and assume that they gave me all the rules that I needed, and then everything just worked. So if I just plowed full steam ahead without overthinking, I might have done a little bit better today, but I was kind of slow. You looked for the A. Yeah, I think that was the easier solution yesterday, but it didn't occur to me. Okay, I think I'm gonna find somebody to raid here. Let's see who else is on. I know Finkel's gonna start in 2 hours and 40 minutes, but I don't know if I can keep talking for that long. I don't know. I don't think anybody else is doing Advent of Code right now. I'm too late on the East Coast. I don't like to do these on midnight at most days, so everybody else is done. I think this is at least software related. Come on, trying to mute this tab. Oh well, I'll just mute here. Okay. CM Griffing is also doing software. JD is a smaller channel though, so I think maybe I'll raid JD. Yeah, that would be cool if they'd rotate the time zone. Seems like that would be fair. Well, you don't want to rotate every day within 1 year because then everybody's sleep schedule gets messed up, and you have people like trying to follow the schedule or the Advent of Code schedule with their sleeping schedule. But if they rotated every year, that would be more fair, I think. Second one you just did 20 minutes ago. Oh yeah, looking for the X in day 4. Okay, so JD is doing some sort of game development. I don't think he's doing Advent of Code, so I'm gonna give him a raid. Let me make sure I spell his name right. JD does dev. Raid JD does dev. When am I streaming again? Probably tomorrow around 6:30 or 7 p.m. Eastern time. So around the same time that I started today. And then I might stream again at midnight tomorrow, like right when the puzzle comes out, as long as I'm not too tired, because it's the weekend and maybe I'll be able to stay up for it. Yeah, so thanks everybody who tuned in. I really appreciate it. I'm going to start the raid now, so I'll catch you next time. Bye.
2. So here.
Streamer's name here. Thank you for the raid.
We got a raid.
Last activity, here go. Now, let's rock.
Welcome in, Raiders. Welcome in, Jeff Irwin. Good to see you. How you doing tonight? How was your stream? What were you up to? Tell me everything, please. For Raiders coming in, those of you who don't know me, I'm JD. I do dev. Birdie on Twitch. Yes, there are. There are a ton of them. And I've got a real one. No, I don't have it set to count, because you know what? We gotta make. Doesn't matter how many people are in the raid, it feels like a lot to me. But welcome in, Jeff Irwin, doing Advent of Code. What language? Zone, right on. Syntran. I'm not familiar with it, but awesome. Yeah, so those of you who don't know me, I'm JD. I'm normally a web developer. That's what I do for a day job, but I'm learning game dev and I'm also doing some weird stuff. Right now, we're working on what I affectionately call my Godot overlay, and I'm trying to get data from OBS over into Godot, which is a game engine that I use to do stuff with. Those are fine. So what's happening here is I've got Spout. You can see me in Godot here. I've got Spout sending data or sending images from OBS over into Godot, and I've also got NVIDIA AR tracking my face.